I'd like to introduce the next session, but before I do, I'd also like to give a big shout out to everyone online. The amount of people attending this is truly staggering and humbling, so thank you. And with that, I'd like to introduce building an IoT product on real-time scalable environmental sensing networks, featuring Julian Cyrus, COO of Lunar Outpost. So with that, I hand it over to Julian.
Hey, Michael, thanks for the introduction. As you mentioned, my name is Julian Cyrus. I am the COO and co-founder of Lunar Outpost. Before we start this presentation, I'd like to say thanks to Lindsay and Michael and all the rest of the Particle folks that took this conference from an in-person meeting and brought it to the online platform. So without further ado, we'll just jump right into the slides. All right, so as Michael mentioned, today, what we'll be talking about is building an IoT product on real-time scalable environmental sensing networks. And so what we're going to be doing is drawing on Lunar Outpost's own experience on our air quality and environmental monitor called the Canary. And we'll be kind of looking at this from a high-level perspective on how to build a product line and how to integrate all of the different kinds of parameters in order to make this successful. Okay, so here's the roadmap that we'll be going over. We'll give you just a brief introduction about the company as a whole, Lunar Outpost, just so you know that how we as a company fit into this picture. I'll talk about the technology a little bit and then get into the main portion of this, which is the product considerations.
Hey, Julian, sorry to interrupt you. We are not seeing your slides.
All right, well, thank you for interrupting me then. All right, so as I was talking through this roadmap here, there's the company overview, the technology itself, and then the product considerations. So product considerations, we'll talk about the how to create a product line that is successful, and we're going to be drawing on our Canary S monitor and kind of using that as kind of the example as we step through that. As with the other talks, we'll have the Q&A will be hosted on Discord at the Environmental Sensing Network channel. So I'll be sure to hop on that right after this, and feel free to, hop on that and we'll have a conversation. So a little bit about Lunar Outpost itself. Lunar Outpost was founded in 2017 with the mission to create technology that enables a long-term human presence in space, specifically the lunar surface. We are headquartered in Golden, Colorado, which is about 25 minutes west of downtown Denver. We have robotics contracts with NASA. We've got instrumentation contracts with the United States Air Force, and we are also working on other things. We got a life support system at Kennedy Space Center aboard NASA's prototype space gateway, and we were a provider for the Bloomberg Smart Cities Initiative. Now we partnered with the City and County of Denver for that. They took the lead and they wanted to measure air quality at local schools, and they wanted to create kind of a social outreach portion of that. And so we were the technology provider for that, and they ultimately ended up being a finalist and winning a Bloomberg Award for that. Now, with kind of a little bit of this background, you might wonder why a company called Lunar Outpost with kind of, some of these space ambitions is in the IoT and environmental sensing industry, and why are we even, giving a presentation at this conference. So to kind of answer that, it really is at the core of what Lunar Outpost does. We create dual use technologies that can be used both on Earth as well as in space. So we do that for a couple reasons. One of them being that we want to have a positive impact here on Earth, as well as we want to have near-term growth for the company. Now, a lot of space companies out there in the past have started, they've had, large ambitions, and then they failed because they did not have a a concrete source of revenue and a good business plan. So while we pursue these longer term and expensive space aspirations, we also have products here on Earth that we're selling and that we're leveraging our expertise for. So on the right, you'll see a picture of MAP, which is our mobile autonomous prospecting platform. It's essentially a lunar rover that goes around the surface of the moon and creates a resource map. And I won't be talking about that today, but if you have questions about that, feel free to hop on Discord with those questions, and I'll answer any questions you have about our other products, about our environmental products, or our company as a whole. Now on the left, you'll see a picture of one of our canaries, which is the product that will be the main focus of this talk. So now we'll hop into the technology a bit. And now the Canary S is what we call our IoT air quality meteorological monitoring line. It's called Canary S because it is solar powered. We also have the Canary E, which is Ethernet based, but we won't talk about that for this talk. Now, this unit is solar powered and it communicates over cellular, which is important so that it is not a, it's a unit that is not reliant upon hardwired infrastructure. So it's very flexible in terms of, you can place it where you'd like. And that, along with the fact that it is, cost effective and compact, these three characteristics really allow it to be deployed in large networks in a variety of locations. And I think that, having, solar powered or some kind of, flexible power and communications, and then being cost effective and compact are really characteristics of not just the Canary, but of any device that you want to make into a network solution, really. A couple other things that it provides is real-time monitoring. It takes readings every second and then relays those once a minute back up to the cloud and then the customer's database, so you're getting instantaneous data almost. It's also modular and flexible. Now, the unit itself, as I mentioned, is air quality meteorological monitor. So what that means is that it's sensing the environment and relaying key pollutants or parameters back to the customer. Now, the base unit, it measures particulate matter, temperature, humidity, pressure, and then I mentioned that it's modular. So on top of the base unit, you can have, it can be outfitted with a variety of speciated gas sensors such as carbon monoxide, ozone, NO2, total VOCs, as well as some of your meteorological measurements like wind speed, direction, and then it has some more specialized abilities as well. So it just gives you a little bit of background on the technology itself. So as we go forward throughout this conversation, you'll be able to frame the entire conversation a little bit better. So now the architecture of the network is what we'll be going over here. We've got kind of a cohort of canaries around there. They communicate over cellular, as was mentioned, with other, if you have other devices, you can use Bluetooth. We don't use those on this, on the Canary S's, but of course, if you had Bluetooth devices, you could have, or a mesh network and communicating amongst each other, you would have alternative forms of communication, which you can do some really interesting things with. Now, the next step is from cellular, the units communicate and the data goes up to the secure cloud. Now, that's where Particle comes in for us. And from there, data is routed to a customer database or API, or to our own air quality platform, which customers can use to view data graphically on a map, or and do some other things as well. The other way that it's kind of a specialized way of routing data, but some customers have had really particular needs, and we've been able to route data from a unit directly to that customer database. But that is just, one-off solutions. Now, for this, I'd like to talk a little bit about where Particle fits into the solution for us. We use them from a hardware standpoint, from the microcontrollers, as well as through the connectivity and the back-end functionality. And that has been, really important for us. When we started out, we were looking at different providers, and we actually used different providers, but we ultimately settled on Particle, not just because the cost and things that you can do with the enterprise solution, but the fact that it was both a hardware, back end, the kind of entire package that, as a company is growing, it can scale with you. And when you're making microcontrollers for as a young company, unless you're making 10,000 at a time, you're not going to be able to get to the price point and really have a system that is vetted from a hardware as well as a software standpoint. And the other thing is you'll notice that there are some arrows here that are not just one-way arrows, they're two-way arrows. And that starts to get into the conversation of doing OTAs, or over-the-air updates, and being able to communicate with your devices that are out in the field and have them perform actions in real time. And that's another thing that is kind of another layer of complexity that you can layer onto your solution and really provide more value, a more tangible value to your customers, as well as make things easier for yourself as a business. So wanted to get into the product considerations now. And this is going to be based off the product life cycle, where, I know a lot of you guys have seen, a diagram similar to this before. Basically, it starts out, you've got a concept, and that concept of a product, as well as customer use cases, which is kind of a market analysis or feedback, feeds into a prototype, test, learn cycle, which is kind of a build, test, learn kind of there. And then that goes into the more mature manufacturing, deploying, supporting of your product. And then it all, kind of, it's a cycle. And so there's arrows everywhere, of course. Now, what we'll do here is we'll talk about this, and we'll use the Canary system as kind of a case study for this. So in doing that, it'll give you a little bit of, it'll give you an example of going through this. And so you'll be able to relate to it a little bit better, I think. So we'll start out with, at the beginning, just the concept and the other things that are going into your preliminary design. Now, some of the things that are going to this is, of course, going to be customer pain points. Now, I didn't give my background. My background was, I got a degree at the University of Texas and then CU Boulder, both in electrical engineering. And then I went on, I worked for Lockheed Martin on the Orion program, which is NASA's next generation of manned spaceflight vehicles. And now, during my engineering courses, as well as during my early stage career, I almost never heard pain points. I know business folks out there, this is kind of like business 101, but from a technical standpoint, a lot of engineers coming out of school think, kind of, if you build it, they will come. What makes a successful product is good tech. Well, that's part of it, but really to make a really successful product, you need to understand what your customers is looking for, or what their needs are, or what's missing out of kind of their equation. And so for us, we were looking at this, and there was overall a need to have more accurate data to combat worsening air quality. And I'm going to take this specifically for this one market segment, which is municipalities. And so the traditional products that they were using were high cost, 100 to 200K, plus you have maintenance. They were large size because they were effectively these pieces of equipment that you had to build what is essentially a shack around. And so because of their large size and high cost, you could only have a few in an area. And I think the city and county of Denver only had 4 in the entire county before they started looking into more cost-effective solutions. And the thing is that air quality, for example, is a really hyper-localized parameter. So you could have one measurement in, one block downtown, and then 2 blocks over, the air quality could be significantly better or worse, depending on what is going on in that scenario. So the solution that we wanted to provide was a distributed network of IoT sensors. And so with that, it gives you real-time mapping, and you're able to have actionable data. And by actionable data, I mean the customer can use it to create real mitigation strategies and have real solutions for their air quality needs. The device is, as I mentioned previously, low cost. It's small, customizable, gives continuous real-time monitoring and flexible method of providing data. And you'll see that some of those points directly address the pain points that were mentioned earlier. They also address some of the pain points that weren't mentioned in this slide. And the map that you see below is not even near saturation in terms of the number of devices that you can employ for this need. You could easily get several times that in the space provided. Now, another thing to take into account is not just the customer pain points, but their expectations. Now, I say caution, expectations may vary. It's, expectations among customers, even among customers in the same market segment, will likely vary. But when you hop between market segments, they're absolutely going to change. And that's not only based off of the customer use case. And for example, some of the customers that we have, I've listed here, the EPA, they use our monitors in regulatory instances. The state of Colorado uses ours for kind of wildfire detection. Project Canary uses our units in the oil and gas sector. And those are just some examples. But each one of those customers has different expectations. And a lot of those expectations are built off their use case, as well as the current system and the current solutions that they have in place. Now, these solutions might be software in nature, they might be hardware, they might be operational, and that are specialized to that own company, but you will see different ones. And this can include things like data access, for example. What kind of platform are they using? Are they using a mobile app? Are they using a web-based application? Are they using, is it a guy going out there with a clipboard? Just the way that data is recorded, the way that they access it and interact with it. And is it real-time data? Is it recorded data? That is really important for your customer, and it's something that you should consider. Now, the next thing is fidelity. It's the accuracy and the reliability of the system, as well as the data that you're getting. When you have customers such as the EPA, of course, they want higher level data or more accurate data. When you have other customers, they might not need that kind of accuracy or reliability. But something that's also going to be changing between them is security. Now, security is one of those things that it's kind of it's talked about more and more these days, but I still think that not enough consideration is brought to it. When you have some customers like the City and County of Denver, they had a social outreach aspect for their units, and they actually wanted to deliver data to the public. Other companies, if you have an industry or someone in like the oil and gas sector, and they're deploying devices, they don't want that data shared. It is it's paramount that you maintain the integrity of your customer relations, and part of that is securing their data. And so you need to make sure, especially when you deploy large networks in areas that are potentially sensitive for a customer, that data is secure. And then the last is value. I mentioned having actionable data, not just data for the sake of producing data. I think that really having sustainable products is being able to have valuable data produced and being able to communicate that. And now this, for example, is an easy way that I can communicate with my customers what value this brings. Now, the graph on the bottom shows spikes of a gas that a sensor was reading. And so when an operator saw that these spikes were happening originally, they sent out a field tech and in this oil and gas field, and they saw that the picture at the top is what they saw. They saw that a cap was actually not installed properly on one of the openings of the pipes. So they replaced that cap, and then at the end of the graph is the result, which the gas leak went away. So that's something that is easily communicated to customers, and it's a good example for you to have as well, to be able to relay the 2 or 3 points of value for your customers. Now, I'd like to get into the next phase, which is kind of the prototype, test and learn of this. Now, as I mentioned, prototype test learn is kind of just based off the build test learn, lean cycle. After the whole purpose though is not such that you're constantly building, testing, and learning and essentially breaking things while they're out and deployed with customers. It's such that you're doing these prototyping and testing things before they are put out to customers, and so you're making mistakes, you're learning before you have a network of things out with a customer, because a network it means that there's a lot of products working in potentially outdoor environment with untrained users. So that's a lot of variables that can come into play, and you want to make sure that even in a lab environment, a benchtop environment, you need to have a really high level of confidence in your units, because with a network you have many devices, and if there's a problem, then that problem is gonna get exponential. So with prototyping, is it's kind of a cool stage in the life cycle. I like it. You're brainstorming, you're coming up with ideas, you're testing them out, and the main thing with prototyping though is that you need to get your priorities in line. You need to say, hey, this is what we're going after. These are the things that we're developing for. and being able to make sure that you're putting your product on the line to success. So you're saying, hey, this is my MVP, this is my minimum viable product, and as such, you know, this is my limited scope, and we'll add functionality on later. I think that is one of the most important things for prototyping. And then for testing, whether it be continual testing throughout the life cycle or upfront, you need to make sure that you have a dedicated test setup. You know, young companies, you might have only a certain amount of inventory of your products, and you might want to, you know, ship and sell as much as possible, but you need to have, you know, versions of that in-house so you can test your software on, you can test, you know, new sensors on, whatever it may be, because one variable alone can alter something, and that variable might be a line of code. Variable might be how you install something. A variable might be a certain component on a PCB. You know, we've had things in the past where we've had a new build and we've had it run for several days, and, you know, in-house fine, and then like at the end of the week something goes wrong. And so if we hadn't done that, then we wouldn't have figured out that there was this issue that only appeared after several days of running. And I say that needs to work at scale. You need to make sure that the product that you're creating ends up working in networks, because that's really the purpose of it, is to have not just one product out there, but to have many products out there, because one product provides value, but many products can provide, you know, X times that number of value. And sometimes it's even a case of 1 + 1 = 3. And so your back end especially needs to be critical, and you need to have a scalable back end, which is something, of course, that Park provides. Now, we'll get into the end of this life cycle here and get into kind of the end of the presentation with that. Now, for manufacturing, I just want to say also for people that don't have experience in manufacturing or the entire life cycle, it's not just a rubber stamp. You need to definitely stay on top of it. There's been times where we've had, you know, manufacturers that didn't give us enough insight into their own operations, and then, you know, and just kind of gave us lip service. Yeah, things are going all right, things are on time, and then things have shown up late. So you need to make sure that you have schedules with them. You need to make sure that you have you know, weekly checkups if necessary, maybe more if you're doing manufacturing out of house. You need to make sure that your QA QC process before it's shipped out to customers is good as well. For deployment, you need to make sure that the documentation, your instructions for customers is good, and then, you know, all the other considerations that go along with that, and then support for products that are out there. I say that customers will mess something up because customers will find a way to mess something up. Users will find a way. You know, even the best laid plans, they'll find a way. But you'll learn something from them. You'll make your system better. From a usability standpoint, you know, and like I mentioned, you know, for those customer expectations, it's really good, especially if you're starting off, to have a continuous dialogue with customers. And if you can get in a, you know, kind of like a pilot study with a customer or two, then that really gets them bought into your product, gets them bought into your company, and then they can eventually be a champion for you going forward as well. And so I think that those are all important considerations. And in terms of, you know, what we've done with the Canary S, those are some of the things that we've seen as well. And so with that, you know, that's kind of the end of the conversation that we have here. But I'd love to talk more if you have questions on the Discord channel that's been set up for us. So thanks, guys.
Terrific. Thank you so much, Julian. That was a great session. We're now going to take a 10-minute break, and then we'll resume with a session featuring Dan Jameson on the opportunities and challenges of tracking high-value assets. So let's meet back here at 2 o'clock. 2 o'clock. Thanks, folks.